When we talk about our models at Ryder, like Palmyra X4 and X5, you'll often hear us talk about something called synthetic data and how it enables us to build really efficient models at a fraction of the cost of some of the big labs. But what is synthetic data? Why should you care about it? And what makes Ryder's approach to synthetic data unique? Well, at NeurIPS 2024, Ilya Sutskever famously said that data is the fossil fuel of AI and that pre-training as we know it is coming to an end. What did he mean by this? Well, the demand for compute continues to grow, but we're actually running out of data. We only have one internet, we've already trained on it, and we're not producing much more human data than we already have in the rest of human history. I love this talk from Lubna at Hugging Face, and she's got this great chart of the different data set size and model size of the different generations of the GPT models. And you can see that there's just orders of magnitude between all of them. Less so between GPT-3 and GPT-4, but still a lot. GPT-2 to GPT-3 was huge. And the same is also true of the increase in inference costs between these different models. You can see just the 100 times more GPUs needed between GPT-2 and GPT-3, and that's also an increase in the time per token. So I love this meme she has of, it's not, the answer is not to build larger models, it's to build more efficient models. And this is something we've actually been doing at Ryder for a long time, and so we agree. So what do we do about this? One solution is synthetic data. So there's this great paper by the Alan Turing Institute and the Royal Society, and I like their definition of synthetic data, where it's data that has been generated using a purpose-built mathematical model or algorithm with the aim of solving a set of data science tasks. This synthetic data, it's purpose-built, it's not hallucinated, and it's not fake, and we'll come back to that. But it's not exactly a silver bullet. There are some risks inherent with synthetic data. Probably the most common risk that you'll hear with synthetic data is something called model collapse. And this is when AI models are just sort of recursively trained on AI-generated data, whether that's output text from models, we're gonna generate content from models, which goes on the internet, and then we train on that content because it's on the internet, and then we continue that process. Or synthetic data, where it's been data produced by AI, and it's just going to recursively train on itself, and there's all kinds of problems that come from that. And this paper in Nature is a great place to learn more about that. So there's a few different things that we do at Ryder about this, and we've built this synthetic data pipeline to mitigate some of these risks. And there's a few different misconceptions that you'll hear about synthetic data. One, I sort of already mentioned that synthetic data is poor quality. And this is not, in fact, the case. We do this thing called verification, where we treat synthetic data as verified data augmentation so that it meets high standards of quality and reliability. And when you do this correctly, the synthetic data can actually not only be as good as real data, but even outperform some of the human-generated data. There's a great paper here called Genie that you can learn more about that. The next one I kind of mentioned earlier, also about synthetic data being fake or hallucinated. This is also a misunderstanding because it's not that this data is just sort of created out of thin air. You make sure that the synthetic data actually includes the different complexities and variations and things like that come along with the real data. So the quality of the synthetic data makes a huge difference because you want it to mimic the properties and the characteristics of the real data. And so this is something that we do at Ryder. We use this proprietary synthetic data pipeline, and it transforms real factual data into synthetic data. The next myth is that models can't be trained solely on synthetic data or that they won't perform as well. And this is also a misconception. There's actually a great paper that shows that synthetic data can be a viable substitute for real data, even up to 80% replacement. And you can read more about that on this paper on the equivalency, substitutability, and flexibility of synthetic data. In fact, we built Palmyra X4 with entirely synthetic data, and it performs really well. It has tool calling, it has a 128K context window, et cetera, et cetera. And we also did a lot of that for X5, which has a 1 million context window. And then the last misconception is around those risks and ethical concerns, mostly around like model collapse. And so there are a few different things that we're doing here. One is that we're doing a lot of research on something called self-evolving models, so that there's careful and continuous integration of the synthetic data. And so in this way, you're going to have this continual learning and new data in the training pipeline as like a self-check system. The other things that we're doing are around regulations, transparency, and having a balanced approach. So we're adhering to these different ethical guidelines and standards. And then we're also transparent with our stakeholders in the use of synthetic data, and then taking that balanced approach where we use synthetic data in conjunction with real data wherever appropriate. I hope that helps. Please let me know what you think. Have you heard of synthetic data? Are you using it yourself? Let me know. I'll put some resources down in the links below, and I look forward to talking to you soon.